Hey, my name is Felipe and welcome to my channel. In this video we are going to train an object detector using Yolov8, and I am going to walk you step by step through the entire process, from how to collect the data you need in order to train an object detector, how to annotate the data using a computer vision annotation tool, how to structure the data into the exact format you need in order to use Yolov8, how to do the training, and I'm going to show you 2 different ways to do it from your local environment and also from a Google Colab, and how to test the performance of the model you trained. So this is going to be a super comprehensive step-by-step guide of everything you need to know in order to train an object detector using Yolov8 on your own custom dataset. So let's get started. So let's start with today's tutorial, let's start with this process, and the first thing we need to do is to collect data. The data collection is the first step in this process. Remember that if you want to train an object detector or any type of machine learning model, you definitely need data. The algorithm, the specific algorithm you're going to use, in this case Yolov8, is very important, but the data is as important as the algorithm. If you don't have data, you cannot train any machine learning model. That's very important. So let me show you the data I am going to use in this process. These are some images I have downloaded and which I'm going to use in order to train this object detector, and let me show you a few of them. These are some images of alpacas. This is an alpaca dataset I have downloaded for today's tutorial, and you can see these are all images containing alpacas in different postures and in different situations, right? So this is exactly the data I am going to use in this process, but obviously you could use whatever dataset you want. You could use exactly the same dataset I am going to use, or you can just collect the data yourself. You could just take your cell phone or your camera or whatever, and you can just take the pictures, the photos, the images you are going to use. You can just do your own data collection. Or something else you could do is to just use a publicly available dataset. So let me show you this dataset. This is the OpenImages dataset version 7, and this is a dataset which is publicly available, and you can definitely use it in order to work on today's tutorial, in order to train the object detector we are going to train on today's tutorial. So let me show you how it looks like. If I go to Explore and I select Detection, you can see that I'm going to unselect all these options. You can see that this is a huge dataset containing many categories. I don't know how many, but they are many. This is a huge dataset. It contains millions of images, hundreds of thousands, if not millions of annotations, thousands of categories. This is a super huge dataset, and you can see that you have many different categories. Now we are looking at trumpet, and you can see these are different images with trumpets, and from each one of these images we have a bounding box around the trumpet. And if I show you another one, for example, we also have beetle. And in this category, you can see we have many different images from many different type of beetles. So this is another example. Or if I show you this one, which is bottle, and we have many different images containing bottles. For example, there you can see many different type of bottles, and in all cases we have a bounding box around the bottle. And I could show you, I don't know how many examples, because there are many different categories. So remember, the first step in this process is the data collection. This is the data I am going to use in this project, which is a dataset of alpacas, and you can use the exact same data I am using. If you want to, you can use the same dataset of alpacas, or you can just collect your own dataset by using your cell phone, your camera, or something like that. Or you can also download the images from a publicly available dataset, for example, OpenImages dataset version 7. If you decide to use OpenImages dataset version 7, let me show you another category, which is alpaca. This is exactly from where I have downloaded all of the images of alpacas. So if in case you decide to use this publicly available dataset, I can provide you with a couple of scripts I have used in order to download all this data, and in order to parse through all the different annotations and through to format this data in the exact format we need in order to work on today's tutorial. So in case you decide to use OpenImages dataset, I am going to give you a couple of scripts which are going to be super useful for you. So that's all I can say about the data collection. Remember, you need to collect data if you want to train an object detector, and you have all those different ways to do it, and all these different categories and all these different options. So now let's move on to the next step. And now let's continue with the data annotation. You have collected a lot of images, as I have over here. You have a lot of images which you have collected yourself, or maybe you have downloaded this data from a publicly available dataset, and now it's the time to annotate this dataset. Maybe you were lucky enough when you were creating the dataset, and maybe this dataset you are using is already annotated. Maybe you already have all the bounding boxes from all of your objects, from all your categories. Maybe that's the case. So you don't really need to annotate your data. But in any other case, for example, if you were using a custom dataset, a dataset you have collected yourself with your own cell phone, your camera, and so on, something you have collected, in that case, you definitely need to annotate your data. So in order to make this process more comprehensive and in order to show you like the entire process, let me show you as well how to annotate data. So we are going to use this tool, which is CBAT. This is a labeling tool. I have used it many times in many projects. I would say it's one of my favorite tools. I have used pretty much absolutely all the object detection, computer vision related annotation tools I have used. Maybe I haven't used them all, but I have used many of them. And if you're familiar with annotation tools, you would know that there are many of them and none of them is perfect. I will say all of the different annotation tools have their advantages and their disadvantages, and for some situations you prefer to use one of them, and for other situations it's better to use another one. CBAT has many advantages and it also has a few disadvantages. I'm not saying it's perfect, but nevertheless this is a tool I have used in many projects and I really like it. So let me show you how to use it. You have to go to cbat.ai and then you select try for free. There are different pricing options, but if you're going to work on your own or in a very small team, you can definitely use the free version. So I have already logged in. This is already logged into my account, but if you don't have an account, then you will have to create a new one. And yeah, so you're going to see like a sign up page, and you can just create a new account, and then you can just log into that account. So once you are logged into this annotation tool, you need to go to projects and then create a new one. I'm going to create a project which is called Alpaca Detector, because this is a project I am going to be working in, and I'm going to add a label, which in my case is going to be only one label, which is alpaca. And then that's pretty much all. Submit and open. I have created the project. It has one label, which is alpaca. Remember, if your project has many different labels, add all the labels you need. And then I will go here, which is create a new task. I am going to create a new annotation task, and I'm going to call this task something like alpaca detector annotation task 001. This is from the project Alpaca Detector, and this will take all the labels from that project. Now you need to upload all the images you are going to annotate. So in my case, I'm obviously not going to annotate all the images, because you can see these are too many images and it doesn't make any sense to annotate all these images in this video. These are 452 images, so I'm not going to annotate them all, but I'm going to select a few in order to show you how exactly this annotation tool works and how exactly you can use it in your project. Also, in my case, as I have downloaded these images from a publicly available dataset, from the Open Images dataset version 7, I already have the annotations. I already have all the bounding boxes. So in my case, I don't really need to annotate this data because I already have the annotations, but I'm going to pretend I don't. So I can just label a few images and I can show you how it works. So now I go back here and I'm just going to select something like this many images, right? Yeah, I'm just going to select these many images. I'm going to open these images and then I'm going to click on submit and open, right? So this is going to create this task, and at the same time it's going to open this task so we can start working on our annotation process. Okay, so this is the task I have just created. I'm going to click here in job number and the job number. and this will open all the images, and now I'm going to start annotating all these images. So we are working on an object detection problem, so we are going to annotate bounding boxes. We need to go here, and for example, if we will be detecting many different categories, we will select what's the category we are going to label now, and that's it. In my case, I'm going to label always the same category, which is alpaca, so I don't really need to do anything here. So I'm going to select shape, and let me show you how I do it. I'm going to click in the upper left corner and then in the bottom right corner. So the idea is to enclose the object and only the object, right? The idea is to draw a bounding box around the object and anywhere else, right? You only want to enclose this object. And you can see that we have other animals in the back, right? We have other alpacas, so I'm just going to label them too. And there is a shortcut which is pressing the letter N, and you can just create a new bounding box. So that's another one, this is another one, this is another alpaca, and this is the last one. Okay. That's pretty much all. So once you're ready, you can just press Ctrl S. That's going to save the annotations. I recommend you to press Ctrl S as often as possible because it's always a good practice. So now everything is saved. I can just continue to the next image. Now I'm going to annotate this alpaca, and I'm going to do exactly the same process. I can start here, obviously. You can just start in whatever corner you want. And I'm going to do something like this. Okay, this image is completely annotated, and I'm going to continue to the next image. In this case, I'm going to annotate this alpaca too. This is not a real alpaca, but I want my object detector to be able to detect this type of objects too. So I'm going to annotate it as well. This is going to be a very good exercise because if you want to work as a machine learning engineer or as a computer vision engineer, annotating data is something you have to do very often, or actually training machine learning models is something you have to do very often. So usually the data annotation is done by other people, right? It's done by annotators, it's done by, I don't know, there are different services you can hire in order to annotate data. But in whatever case, whatever service you use, it's always a very good practice to annotate some of the images yourself, right? Because if you annotate some of the images yourself, you are going to be more familiar with the data, and you're also going to be more familiar on how to instruct the annotators on how to annotate this particular data. For example, in this case, it's not really challenging. We just have to annotate these two objects, but let me show you. There will be other cases because there will be always situations which are a little confusing. In this case, it's not confusing either. I have just to label that object. But for example, a few images ago when we were annotating this image, if an annotator is working on this image, it's that person is going to ask you, what do I do here? Should I annotate this image or not? Right? If an annotator is working on this image and the instructions you provide, they are not clear enough, this person is going to ask you, hey, what do I do here? Should I annotate this image or not? Is this an alpaca or not? So, for example, that situation, another situation will be what happened here, which we had many different alpacas in the background, and some of them, for example, this one is a little occluded. So there could be an annotator, someone who asks you, hey, do you want me to annotate absolutely every single alpaca, or maybe I can just draw a huge bounding box here in the background and just say everything in the background is an alpaca. Something like that. When an annotator is working on the images, they are going to have many different questions regarding how to annotate the data, and they are all perfect questions and very good questions because this is exactly what's about. I mean, when you are annotating data, you are defining exactly what are the objects you are going to detect, right? So what I'm going is that if you annotate some of the images yourself, you are going to be more familiar on what are all the different situations, on what exactly is going on with your data, so you are more clear in exactly what are the objects you want to detect, right? So let's continue. This is only to show a few examples. This is another situation. In my case, I want to say that both of them are alpacas, so I'm just going to say something like this. But there could be another person who says, no, this is only one annotation, it's something like this, right? I'm just going to draw one bounding box enclosing both of them, something like that. And it will be a good criteria. I mean, it will be a criteria, which I guess it will be fine. But whatever your criteria would be, you need one, right? You need a criteria. So while you are annotating some of the images, is that you are going to further understand what exactly is an alpaca, what exactly is the object you want to consider as alpaca. So I'm just going to continue. This is another case which may not be clear, but I'm just going to say this is an alpaca, this black one, which we can only see this part and we don't really see the head, but I'm going to say it's an alpaca anyway. This one too, this one too, this one too. Also, this is something that always happens to me when I am working, when I am annotating images, that I am more aware of all the diversity of all these images. For example, this is a perfect example because we have an alpaca which is being reflected on a mirror, and it's only like a very small section of the alpaca. It's only like a very small piece of the alpaca's face. So what do we do here? I am going to annotate this one too, because yeah, that's my criteria. But another person could say, no, this is not the object I want to detect. This is only the object I want to detect. And maybe another person would say, no, this is not an alpaca. Alpacas don't really apply makeup on them. This is not real, so I'm not going to annotate this image. You get the idea, right? There could be many different situations, and the only way you get familiar with all the different types of situations is if you annotate some images yourself. So now let's continue. In my case, I'm going to do something like this, because yeah, I will say the most important object is this one, and the other ones are like, yeah, it's not really that important if we detect them or not. Okay, so let's continue. This is very similar to another image. I don't know how many I have selected, but I think we have only a few left. I don't know if these type of animals, they are like natural. I'm very surprised about this, like the head, right? It's like it has a lot of hair over here, and then it's completely hairless, the entire body. I mean, I don't know, I'm surprised. Maybe they are made like that, or maybe it's like a natural alpaca. Who cares, let's continue. So we have, let's see how many. We have only a few left, so let's continue. Let's see if we find any other strange situation which we have to define if that's an alpaca or not, so I can show you an additional example. Also, when you are annotating, you could define your bounding box in many different ways. For example, in this case, we could define it like this. We could define it like this. I mean, we could define it super fit to the object, something like this. Super fit, and we could enclose exactly the object, or we could be a little more relaxed, right? For example, something like this will be okay too, and if we want to do it like this, it will be okay too, right? You don't have to be super accurate. You could be like a little more relaxed, and it's going to work anyway. Now in this last one, and that's pretty much all. And this is the last one. Okay. I'm going to do something like this. No, I'm going to do it like this. I think this is also alpaca, but anyway, I'm just going to annotate this part. So that's pretty much all. I'm going to save. And those are the few images I have selected in order to show you how to use this annotation tool. So that's pretty much all for the data annotation. And remember, this is also a very important step. This is a very important task in this process, because if we want to train an object detector, we need data and we need annotated data. So this is a very important part in this process. Remember this tool, CBAT. This is only one of the many available image annotation tools. You can definitely use another one if you want. It's perfectly fine. It's not like you have to use this one at all. You can use whatever annotation tool you want. But this is a tool I think it's very easy to use. I like the fact it's very easy to use. It's also a web application, so you don't really need to download anything to your computer. You can just go ahead and use it from the web. That's also one of its advantages. So yeah, so this is the tool I show you in this video how to use in order to train this object detector. So this is going to be all for this step, and now let's continue with the next part in this process. And now that we have collected and annotated all of our data, now it comes the time to format this data, to structure this data into the format we need in order to train an object detector using Yolov8. When you're working in machine learning and you're training a machine learning model, every single algorithm you work with is going to have its own requirements on how to input the data. That's going to happen with absolutely every single algorithm you will work with. It's going to happen with YOLO, with all the different YOLO versions, and it's going to happen with absolutely every single algorithm you are working with. So specifically, Yolov8 needs the data in a very specific format. So I created this step in this process so we can just take all the data we have generated, all the images and all the annotations, and we can convert all these images into the format we need in order to input this data into Yolov8. So let me show you exactly how we are going to do that. If you have annotated the data using CVAT, you have to go to Tasks, and then you have to select this option, and it's Export Task Dataset. It's going to ask you the export format, so you can export this data into many different formats, and you're going to scroll all the way down, and you're going to choose YOLO 1.1, right? Then you can also save the images, but in this case it's not really needed. We don't really need the images, we already have the images, and you're just going to click OK. Now, if you wait a few seconds or a few minutes, if you have a very large dataset, you are going to download a file like this, and if I open this file, you're going to see all these different files, right? You can see we have 4 different files, or actually 3 files and a directory, and if I open the directory, this is what you are going to see, which is many different file names. And if I go back to the images directory, you will see that all these images file names, they all look pretty much the same, right? You can see that the file name, the structure for this file name looks pretty much the same as the ones we have just downloaded from CVAT. So basically the way it works is that when you are downloading this data into this format, into the YOLO format, every single annotation file is going to be downloaded with the same name as the image you have annotated, but with a different extension. So if you had an image which was called something.jpg, then the annotation file for that specific image will be something.txt, right? So that's the way it works. And if I open this image, you are going to see something like this. You're going to see, in this case, only one row, but let me show you another one which contains more than one annotation. I remember there were many, for example, this one, which contains 2 different rows, and each one of these rows is a different object. In my case, as I only have alpacas in this dataset, each one of these rows is a different alpaca, and this is how you can make sense of this information. The first character is the class you are detecting. I wanted to enlarge the entire file, and I don't know what I'm doing. There, okay. Okay, the first number is the class you are detecting. In my case, I only have one, so it's only a 0 because it's my only class. And then these 4 numbers which define the bounding box, right? This is encoded in the YOLO format, which means that the first 2 numbers are the position of the center of the bounding box. Then you have the width of your bounding box, and then the height of your bounding box. This, you will notice, these are all float numbers. And this basically means that it's relative to the entire size of the image. So these are the annotations we have downloaded, and this is in the exact same format we need in order to train this object detector. So remember, when I was downloading these annotations, we noticed there were many different options. All of these different options are different formats in which we could save the annotations, and this is very important because you definitely need to download YOLO, because we are going to work with YOLO, and everything is pretty much ready as we need it in order to input into Yolov8, right? If you select YOLO, that's exactly the same format you need in order to continue with the next steps. And if you have your data into a different format, maybe if you have already collected and annotated your data and you have your data in whatever other format, please remember you will need to convert these images, or actually to convert these annotations, into the YOLO format. Now, this is one of the things we need for the data. This is one of the things we need in order to, we need to format in order to structure the data in a way we can use this object detector with Yolov8. But another thing we should do is to create very specific directories containing this data, right? We are going to need two directories. One of them should be called images and the other one should be called labels. You definitely need to input these names. You cannot choose whatever name you want. You need to choose these two names, right? The images should be located in a directory called images, and the labels should be located in a directory called labels. That's the way Yolov8 works. So you need to create these two directories. Within your images directory is where we are going to have your images. If I click here, you can see that these are all my images. They are all within the images directory. They are all within the train directory, which is within the images directory. This directory is not absolutely needed, right? You could perfectly take all your images, all these images, and you could just paste all your images here, right in the images directory, and everything will be just fine. But if you want, you could do something exactly as I did over here, and you could have an additional directory which is in between images and your data and your images, and you can call this whatever way you want. This is a very good strategy in case you want to have, for example, a train directory containing all the training images, and then another directory which could be called validation, for example, and this is where you are going to have many images in order to validate your process, your training process, your algorithm, and you could do the same with an additional directory which could be called test, for example. Or you can just use these directories in order to label the data, right? To create different versions of your data, which is another thing which is very commonly done. So you could create many directories for many different purposes, and that will be perfectly fine, but you could also just paste all the images here, and that's also perfectly fine. And you can see that for the labels directory, I did exactly the same. We have a directory which is called train, and within this directory is that we have all these different files. And for each one of these files, let me show you like this, it's going to be much better. For each one of these files, for each one of these txt files, we will have an image in the images directory, which is called exactly the same file name, but a different extension, right? So in this case, this one is called .txt and this one is called .jpg, but you can see that it's exactly the same file name. For example, the first image is called OA2 EA8F and so on, and that's exactly the same name as for the first image in the images directory, which is called OA2EA8 and so on. So basically, for absolutely every image in your images directory, you need to have an annotations file and a file in the labels directory, which is called exactly the same, but with a different extension. If your images are .jpg, your annotations files are .txt. So that's another thing which also defines the structure you need for your data, and that's pretty much all. So remember, you need to have two directories. One of them is called images, the other one is called labels. Within the images directory is where you're going to have all your images, and within your labels directory is where you will have all your annotations or your labels. And for absolutely every single image in your images directory, you will need to have a file in the labels directory which is called exactly the same but with a different extension. If your images are .jpg, your annotations file should be .txt, and the labels should be expressed in the YOLO format, which is as many rows as objects in that image, And every single one of these rows should have the same structure. You are going to have 5 terms. The first one of them is the class ID. In my case, I only have one class ID. I'm only detecting alpacas. So in my case, this number will always be 0. But if you're detecting more than one class, then you will have different numbers. Then you have the position, the X and Y position of the center of the bounding box. And then you will have the width, and then you will have the height, and everything will be expressed in relative coordinates. So basically this is a structure you need for your data, and this is what this step is about. So that's pretty much all about converting the data, or about formatting the data. And now let's move on to the training. Now is where we are going to take all this data and we are going to train our object detector using Yolov8. So now that we have taken the data into the format we need in order to train Yolov8, now comes the time for the training. Now it comes the time where we are going to take this custom dataset and we are going to train an object detector using Yolov8. So this is Yolov8 official repository, and one of the things I like the most about Yolov8 is that in order to train an object detector, we can do it either with Python, with only a few Python instructions, or we can also use a command line utility. Let me see if I find it over here. We can also execute a command like this in our terminal, something that looks like this, and that's pretty much all we need to do in order to train this object detector. That's something I really liked. That's something I'm definitely going to use in our projects from now on, because I think it's a very convenient and a very easy way to train an object detector or a machine learning model. So this is the first thing we should notice about Yolov8. There are 2 different ways in which we can train an object detector. We can either do it in Python, as we usually do, or we can run a command in our terminal. I'm going to show you both ways, so you're familiar with both ways. And also I mentioned that I am going to show you the entire process on a local environment in a PyCharm project, and I'm also going to show you this process in a Google Colab. So I know there are people who prefer to work in a local environment. I am one of those people, and I know that there are other people who prefer to work on a Google Colab. So depending on in which group are you, I am going to show you both ways to do it, so you can just choose the one you like the most. So let's start with it, and now let's go to PyCharm. This is a PyCharm project I created for this training, and this is the file we are going to edit in order to train this object detector. So the first thing I'm going to do is to just copy a few lines. I'm just going to copy everything, and I'm going to remove everything we don't need. Copy and paste. So we want to build a new model from scratch. So we are going to keep this sentence, and then we are going to train a model. So we are just going to remove everything but the first sentence. And that's all. Right? These are the 2 lines we need in order to train an object detector using Yolov8. Now we are going to do some adjustments. Obviously the first thing we need to do is to import Ultralytics, which is a library we need to use in order to train a Yolov8 model. And this is a Python library we need to install as we usually do. We go to our terminal and we do something like pip install and the library name. In my case, nothing is going to happen because I have already installed this library. But please remember to install it, and also please mind that when you are installing this library has many dependencies, so you are going to install many different Python packages. So it's going to take a lot of space, so definitely please be ready for that, because you need a lot of available space in order to install this library, and it's also going to take some time because you are installing many different packages. But anyway, let's continue. Please remember to install this library, and these are the 2 sentences we need in order to run this training from a Python script. So this sentence, we're just going to leave it as it is. This is where we are loading the specific Yolov8 architecture, the specific Yolov8 model we are going to use. You can see that we can choose from any of all of these different models. These are different versions, or these are different sizes for Yolov8. You can see we have nano, small, medium, large, or extra large. We are using the nano version, which is the smallest one, or is the lightest one. And this one we are going to use the Yolov8 Nano, the Yolov8N. Then about the training, about this other sentence, we need to edit this file, right? We need a YAML file which is going to contain all the configuration for our training. So I have created this file and I have named this file config.yaml. I'm not sure if this is the most appropriate name, but anyway, this is the name I have chosen for this file. So what I'm going to do is just edit this parameter, and I'm going to input config.yaml. This is where the config YAML is located. This is where the main.py is located. They're in the same directory. So if I do this, it's going to work just fine. And then let me show you the structure for this config.yaml. You can see that this is a very simple configuration file. We only have a few keys, which are path, train, val, and then names, right? Let's start with the names. Let's start with this. This is where you are going to set all your different classes, right? You are training an object detector. You are detecting many different categories, many different classes. And this is where you are going to input. This is where you're going to type all of those different classes. In my case, I'm just detecting alpacas. That's the only class I am detecting. So I only have one class, is the number 0, and it's called alpaca. But if you're detecting additional objects, please remember to include all the list of all the objects you are detecting. Then about these three parameters, these three arguments, the path is the absolute path to your directory containing images and annotations. And please remember to include the absolute path. I ran some issues when I was trying to specify a relative path, relative from this directory, from my current directory where this project is created, to the directory where my data is located. When I was using a relative path, I had some issues, and then I noticed that there were other people having issues as well. I noticed that in the GitHub repository from Yolov8, I noticed this in the issues section. There were other people having issues when they were specifying a relative path. So the way I fix it, and it's a very good way to fix it, it's a very easy way to fix it, is just specifying an absolute path. Remember, this should be an absolute path. So this is the path to this directory, to the directory containing the images and the labels directories. So this is the path you need to specify here, and then you have to specify the relative path from this location to where your images are located, like the specific images are located, right? In my case, they are in images./train relative to this path. If I show you this location, which is my root directory, then if I go to images train, this is where my images are located, right? So that's exactly what I need to specify. And then you can see that this is the train data. This is the data the algorithm is going to use as training data. And then we have another keyword, which is val, right? The validation data set, in this case, we are going to specify the same data as we use for training. And the reason I'm doing this is because we want to keep things simple in this tutorial. I'm just going to show you the entire process of how to train an object detector using Yolov8 on a custom dataset. I want to keep things simple, so I'm just going to use the same data. So that's pretty much all for this configuration file. Now going back to main, that's pretty much all we need in order to train an object detector using Yolov8 from Python. That's how simple it is. So now I'm going to execute this file. I'm going to change the number of epochs. I'm going to do this for only one epoch, because the only thing I'm going to show you for now is how this runs. I'm going to show you the entire process. And once we notice how everything is working, once we notice everything is up and running, everything is working fine, we can just continue. But let's just do this process. Let's just do this training for only one epoch so we can continue. You can see that now it's loading the data. It has already loaded the data. You can make use of all the different information, of all these different debugging information we can see here. You can see now we were loading 452 images, and we were able to load all the images, right? 452 from 452. And if I scroll down, you can see that we have additional information, additional values, which are related to the training process. This is how the training process is going, right? We are training this object detector, and this is additional information which we are given through this process. So for now, the only thing we have to do is only waiting. We have to wait until this process is completed. So I am going to stop this video now, and I'm going to fast forward this video until the end of this training, and let's see what happens. Okay, so the training is now completed, and you can see that we have an output which says results saved to runs detect train 39. So if I go to that directory, runs detect and train 39, you can see that we have many different files, and these are files which are related to how the training process was done, right? For example, if I show you these images, these are a few batches of images which were used in order to train this algorithm. You can see the name is train batch 0 and train batch 1, and I think we have a train batch 2. So we have a lot of different images of a lot of different alpacas of different images we use for training, and they were all put together, they were all concatenated into these huge images, so we can see exactly the images which were used for training and the annotation on top of them, right? The bounding boxes on top of them. And we also have similar images, but for the validation dataset, right? Remember, in this case, we are using the same data as validation as we use for training, so it's exactly the same data, it's not different data. But these were the labels in the validation dataset, which is the training dataset, and these were the prediction on these same images, right? You can see that we are not detecting anything. We don't have absolutely any prediction. We don't have absolutely any bounding box. This is because we are doing a very shallow training. We are doing a very dummy training. We are training this algorithm only for one epoch. This was only an example to show you the output, how it looks like, to show you the entire process, but this is not a real training. But nevertheless, these are some files I'm going to show you better when we are in the next step. For now, let me show you how the training is done from the command line, from the terminal, using the command I show you over here, using a command like this. And also let me show you how this training is done on a Google Colab. So going to the terminal, if we type something like this, YOLO detect train data, I have to specify the configuration file, which is config.yaml, and then model.yolov8 n.yaml, and then the number of epochs. This it's exactly the same as we did here, exactly the same. It's going to produce exactly the same output. I'm just going to change the number of epochs for 1, so we make it exactly the same. And let's see what happens. You can see that we have exactly the same output. We have loaded all the images, and now we are starting a new training process. And after this training process, we are going to have a new run, which we have already created a new directory, which is train 40. And this is where we are going to save all the information related to this training process. So I'm not going to do it because it's going to be exactly the same as the one we did before. But this is exactly how you should use the command line, or how you can use this utility in order to do this training from the terminal. You can see how simple it is. It's amazing how simple it is. It's just amazing. And now let me show you how everything is done from a Google Colab. So now let's go back to the browser so I can show you this notebook I created in order to train Yolov8 from a Google Colab. If you're not familiar with Google Colab, the way you can create a new notebook is going to go Google Drive. You can click New, More, and you select the option Google Collaboratory. This is going to create a new Google Colab notebook, and you can just use that notebook to train this object detector. Now let me show you this notebook, and you can see that it contains only 1, 2, 3, 4, 5 cells. This is how simple this will be. The first thing you need to do is to upload the data you are going to use in order to train this detector. It's going to be exactly the same data as we used before. So these are exactly the same directories, the images directory and the labels directory we used before. And then the first thing we need to do is to execute this cell, which mounts Google Drive into this instance of Google Colab. So the only thing I'm doing is just I just pressed enter into this cell, and this may take some time, but it's basically the only thing it does is to connect to Google Drive, so we can just access the data we have in Google Drive. So I'm going to select my account and then allow, and that's pretty much all. Then it all comes to where you have the data in your Google Drive, right? In the specific directory where you have uploaded the data. In my case, my data is located in this path, right? This is my home in Google Drive, and then this is the relative path to the location of where I have the data and where I have all the files related to this project. So remember to specify this root directory as the directory where you have uploaded your data, and that's pretty much all. And then I'm just going to execute this cell. So I save this variable. I'm going to execute this other cell, which is pip install ultralytics, the same command I run from the terminal in my local environment. Now I'm going to run it in Google Colab. Remember, you have to start this command by the exclamation point, which means you are running a command in the terminal where this process is being executed or where this notebook is being launched. So remember to include the exclamation point. Everything seems to be okay, everything seems to be ready, and now we can continue to the next cell, which is this one. You can see that we have done exactly the same structure. We have input exactly the same lines as in our local environment. If I show you this again, you can see we have imported ultralytics, then we have defined this YOLO object, and then we have called model.train, and this is exactly the same as we are doing here. Obviously, we are going to need another YAML file. We are going to need a YAML file in our Google Drive, and this is the file I have specified, which has it's like exactly the same configuration as in the YAML file I show you in my local environment. It's exactly the same idea. So this is exactly what you should do. Now you should specify an absolute path to your Google Drive directory. That's the only difference. So that's the only difference. And I see I have a very small mistake because I see I have data here, and here I have just uploaded images and labels in the directory, but they are not within another directory which is called data. So let me do something. I'm going to create a new directory which is called data, images, labels. I'm just going to put everything here. Right, so everything is consistent. So now everything is okay. Images, then train, and then the images are within this directory. So everything is okay. Now let's go back to the Google Colab. Every time you make an edit or every time you do something in Google Drive, it's always a good idea to restart your runtime. So that's what I'm going to do. I'm going to execute the commands again. I don't really need to pip install this library again because it's already installed into this environment. And then I'm going to execute this file. I think I have to do an additional edit, which is this file. Now it's called googlecolab.config. And that's pretty much all. I'm just going to run it for one epoch. So everything is exactly the same as we did in our local environment. And now let's see what happens. So you can see that we are doing exactly the same process. Everything looks pretty much the same as it did before. We are loading the data. We are just loading the models. Everything is going fine. And this is going to be pretty much the same process as before. You can see that now we are, it takes some additional time to load the data because now you are running this environment, you are running this notebook in a given environment, and you're taking the data from your Google Drive. So it takes some time. It's a slower process, but it's definitely the same idea. So the only thing we need to do now is just to wait until all this process to be completed, and that's pretty much all. I think it doesn't really make any sense to wait because it's going to be exactly the same process as we did from our local environment. At the end of this execution, we are going to have all the results in a given directory, which is the directory of the notepad which is running this process. So at the end of this process, please remember to execute this command, which is going to take all the files you have defined in these runs directory which contains all the runs you have made, all the results you have produced, and it's going to take all this directory into the directory you have chosen for your files and your data and your Google Colab and so on. Please remember to do this because otherwise you would not be able to access this data. And this is the data which contains all the results and everything you have just trained. So this is how you can train Yolov8, an object detector using Yolov8 in a Google Colab, and you can see that the process is very straightforward and it's pretty much exactly the same process, exactly the same idea as we did in our local environment. And that's it. So that's how easy it is to train an object detector using Yolov8 once you have done everything we did with the data, right? Once you have collected the data, you have annotated the data, you have taken everything into the format Yolov8 needs in order to train an object detector. Once everything is completed, then running this process, running this training is super straightforward. So that's going to be all about this training process, and now let's continue with the testing. Now let's see how these models we have trained, how they performed, right? Let's move to the next step. And this is the last step in this process. This is where we are going to take the model we produced in the training step and we're going to test how it performs. This is the last step in this process. This is how we are going to complete this training of an object detector using Yolov8. So once we have trained a model, we go to this directory. Remember to the directory I showed you before regarding the directory where all the information was saved, where all the information regarding this training process was saved. And obviously I'm not going to show you the training we just did because it was like a very shallow training, like a very dummy training, but instead I'm going to show you the results from another training I did when I was preparing this video, where I conducted exactly the same process, but the training process was done for 100 epochs. So it was like a more deeper training, right? So let me show you all the files we have produced so you know what are all the different tools you have in order to test the performance of the model you have trained. So basically you have a confusion matrix which is going to give you a lot of information regarding how the different classes are predicted or how all the different classes are confused, right? If you are familiar with how a confusion matrix looks like or it should look like, then you will know how to read this information. Basically, this is going to give you information regarding how all the different classes were confused. In my case, I only have one class, which is alpaca, but you can see that this generates another category, which is like a default category, which is background, and we have some information here. It doesn't really say much, it says how these classes are confused, but given that this is an object detector, I think the most valuable information is in other metrics, in other outputs. So we are not really going to mind this confusion matrix. Then you have some plots, some curves. For example, this is the F1 confidence curve. We are not going to mind this plot either. Remember, we are just starting to train an object detector using Yolov8. The idea for this tutorial is to make it like a very introductory training, a very introductory process. So we are not going to mind in all these different plots we have over here because it involves a lot of knowledge and a lot of expertise to extract all the information from these plots. And it's not really the idea for this tutorial. Let's do things differently. Let's focus on this plot, which is also available in the results which were saved into this directory. And you can see that we have many different plots. You can definitely go crazy analyzing all the information you have here because you have 1, 2, 3, 4, 5, 10 different plots. You could knock yourself out analyzing and just extracting all the information from all these different plots. But again, the idea is to make it a very introductory video and a very introductory tutorial. So long story short, I'm just going to give you one tip of something, the one thing you should focus on these plots for now. If you're going to take something from this video, from this how to test the performance of a model you have just trained using Yolov8 to train an object detector, is this. Make sure your loss is going down, right? You have many plots, some of them are related to the loss function, which are this one, and this one. This is for the training set. and these are ready for the validation set. Make sure all of your losses are going down, right? This is like a very, I would say, a very simple way to analyze these functions or to analyze these plots. But that's, I will say that that's more powerful than it will appear. Make sure all your losses are going down, because given the loss function, we could have many different situations. We could have a loss function which is going down, which I will say it's a very good situation. We could have a loss function which started to go down and then just it looks something like a flat line. And if we are in something that looks like a flat line, it means that our training process has stuck. So it could be a good thing, because maybe the algorithm, the machine learning model already learned everything it had to learn about this data. So maybe a flat line is not really a bad thing. Maybe, I don't know, you will have to analyze other stuff. Or if you look at your loss function, you could also have a situation where your loss function is going up, right? That's the other situation. And if you, my friend, have a loss function which is going up, then you have a huge problem. Then something is obviously not right with your training. That's why I'm saying that analyzing your loss function, what happens with your loss, is going to give you a lot of information. Ideally, it should go down. If it's going down, then everything is going well, most likely. If it's something like a flat line, well, it could be a good thing or a bad thing. I don't know. We could be in different situations. But if it's going up, you have done something super wrong. I don't know what's going on in your code. I don't know what's going on in your training process, but something is obviously wrong, right? So that's like a very simple and a very naive way to analyze all this information, but trust me, that's going to give you a lot of information in order to start working on this, testing the performance of this model. But I will say that looking at the plots and analyzing all this information and so on, I will say that's more about research. But that's what people who do research like to do. And I'm more like a freelancer. I don't really do like research. So I'm going to show you another way to analyze this performance or this the model we have just trained, which from my perspective, it's a more it makes more sense to analyze it like this. And it involves to see how it performs with real data, right? How it performs with data you have used in order to make your inferences and to see what happened. So the first step in this more practical, more visual evaluation of this model, of how this model performs, is looking at these images. And remember that before, when we looked at these images, we had this one which was regarding the labels in the validation set. And then this other one, which were the predictions, were completely empty. Now you can see that the predictions we have produced, they are not completely empty, and we are detecting the position of our alpacas super accurately. We have some mistakes actually. For example, here we are detecting a person as an alpaca. Here we are detecting also a person as an alpaca, and we have some misdetections. For example, this should be an alpaca and it's not being detected. So we have some misdetections, but you can see that the results are pretty much okay, right? Everything looks pretty much okay. The same about here. If we go here, we are detecting pretty much everything. We have a misdetection here. We have an error over here because we are detecting an alpaca where there's actually nothing. So things are not perfect, but everything seems to be pretty much okay. That's the first way in which we are going to analyze the performance of this model, which is a lot, because this is like a very visual way to see how it performs. We are not looking at plots. We are not looking at metrics, right? We are looking at real examples and to see how this model performs on real data. Maybe I am biased to analyze things like this because I'm a freelancer, and the way it usually works when you are a freelancer is that if you are building this model to deliver this project for a client and you tell your client, oh yeah, the model was perfect, take a look at all these plots, take a look at all these metrics, everything was just amazing, and then your client tests the model and it doesn't work, the client will not care about all the pretty plots and so on, right? So that's why I don't really mind a lot about these plots. Maybe I am biased because I am a freelancer and that's how freelancing works. But I prefer to do like a more visual evaluation. So that's the first step we will do, and we can notice already we are having a better performance. We are having an okay performance. But this data we are currently looking at right now, remember the validation data, it was pretty much the same data we use as training, so this doesn't really say much. I'm going to show you how it performs on data which the algorithm have never seen, with completely and absolutely unseen data. And this is a very good practice if you want to test the performance of a model. So I have prepared a few videos. So let me show you these videos. They are basically, remember this is completely unseen data. And this is the first video. You can see that this is an alpaca, which is just being an alpaca, which is just walking around. It's doing its alpaca stuff. It's having an alpaca everyday life. It's just being an alpaca, right? It's walking around from one place to the other, doing nothing. No, it's doing its alpaca stuff, which is a lot. This is one of the videos I have prepared. This is another video which is also an alpaca doing alpaca related stuff. So this is another video we are going to see. Remember, this is completely unseen data. And I also have another video over here. So I'm going to show you how this model performs on these three videos. I have made a script in Python which loads these videos and just calls the predict method from Yolov8. From Yolov8, we are loading the model we have trained, and we are applying all the predictions to this model, and we are seeing how it performs on these videos. So this is the first video I show you, and these are the detections we are getting. You can see we are getting an absolutely perfect detection. Remember, this is completely unseen data, and we are getting, I'm not going to say a 100% perfect detection because we are not, but I would say it's pretty good. I would say it's pretty good in order to start working on this training process. Yeah, I would say it's pretty good. So this is one of the examples. Then let me show you another example, which is this one. And this is the other video I show you. And you can see that we are also detecting exactly the position of the alpaca. In some cases, the text is going outside of the frame because we don't really have space, but everything seems to be okay in this video too. So we are detecting exactly the position of this alpaca. The bounding box in some cases is not really fit to the alpaca face, but yeah, but everything seems to be working fine. And then the other video I show you, you can see in this case the detection is a little broken. We have many misdetections, but now everything is much better. And yeah, in this case it's working better too. It's working well. I will say in these three examples, this one it's the one that's performing better. And then the other one, I really like how it performed too, in this case where the alpaca was like starting its alpaca journey. And yeah, we had like a very good detection and a very stable detection. Then it like breaks a little, but nevertheless, I would say it's okay. It's also detecting this alpaca over here. So I would say it's working pretty much okay. So this is pretty much how we are going to do the testing in this phase. Remember that if you want to test the performance of the model you have just trained using Yolov8, you will have a lot of information in this directory, which is created when you are training the model. At the end of your training process, you will have all of these files, and you will have a lot of information to knock yourself out to go crazy analyzing all these different plots and so on. Or you can just keep it simple and just take a look at what happened with the training loss and the loss and the validation loss and so on, all the loss functions. Make sure they are going down. That's the very least thing you need to make sure of. And then you can just see how it performs with a few images or with a few videos. Take a look how it performs with unseen data, and you can make decisions from there. Maybe you can just use the model as it is, or you can just decide to train it again. In this case, if I analyze all this information, I see the loss functions are going down, and not only they are going down, but I notice that there's a lot of space to improve this training, to improve the performance, because we haven't reached that moment where everything just appears to be stuck, right? Like that flat line. We are very far away from there. So that's something I will do. I will do an even deeper training so we can just continue learning about this process. Also, I will change the validation data for something that's completely different from the training data, so we have more information. And that's pretty much what I will do in order to iterate and in order to make a better model and a more powerful model. So this is going to be all for today. My name is Felipe, I'm a computer vision engineer. If you enjoyed this video, please remember to click the like button. It's going to help me a lot, it's going to help the channel, and you know how it is. So this is going to be all for today. In this channel I make tutorials, coding tutorials, which are related to computer vision and machine learning. I also share my experience as a computer vision engineer. I talk about different things related to computer vision or machine learning. So if you're curious to know more about these topics, please consider to subscribe to my channel. This is going to be all for today, and see you on the next video.